The Single Tracks podcast is brought to you by TPC, the Pros Closet. Spring is the perfect time to upgrade, and TPC has an industry-leading selection of new and certified pre-owned bikes, plus frames, wheels, and accessories. Each certified pre-owned bike is inspected, tested, and serviced, and every bike includes 30-day returns. Visit tpc.bike/singletracks and enter code singletracks40 to save $40 on every order over $200. That's the Pros Closet at tpc.bike/singletracks, and look for the link and coupon code in the show notes. Hey everybody, welcome to the Single Tracks podcast. My name is Jeff, and today my guest is Chris Mandell. Chris is the rear shock product manager at SRAM RockShox, where he's worked for the past 8 years. He currently lives and rides in Bellingham, Washington. Thanks for joining us, Chris.
Yeah, no problem. I'm actually the former rear shock product manager. I am currently the North American public relations person, but I was the rear shock product manager for 4.5 years, and Lindsay Watson placed me as the rear shock product manager just a little bit ago, and I'm really stoked to have her replace me.
Well, thanks for the clarification. I guess I should tell you maybe you need to update your LinkedIn profile.
I do need to update my LinkedIn profile. It's not a thing that I look at very often. That role was huge for me, and I had a really good time working on that team. You know, it's like pretty fast-paced environment working in the RockShox product development space, especially on the rear shock side of things. You know, in terms of development, you know, you're working on a lot of projects that are specifically for RockShox and the RockShox product line, but then we also do quite a few specific projects for our OEM partners where we're working on products that are specifically for their bikes. Yeah, a really good example of this would actually be the Wicked rear shock that the rear shock team just completed for Specialized on their new Epic World Cup.
Yeah, for sure. And obviously, you know, this podcast, we're going to be talking about mountain bike suspension. And so, yeah, that experience obviously is a big part of your expertise and why we're stoked to have you here. So tell us a little more about your background. Like, how did you get started sort of working in bikes and suspension and all that stuff?
Yeah, totally. So I followed a pretty similar trajectory probably to a lot of people who are in the bike industry. I, in college, was working at a bike shop and, you know, had originally gone to college to play American football, found really quickly that I didn't like that, kind of switched to mountain biking, or I didn't like it at the collegiate level, I should say, and switched to mountain biking, not just kind of like found it and started riding single track and really, really enjoyed it. And then right after college, I went from working at a bike shop to working at Full Speed Ahead, and then worked there for a few years as an inventory manager, and then became a product manager at Kona Bikes and did that for about 6 years, which was really formative and a great learning experience for me. And then in 2015, I joined RockShox as the rear shock product manager and did that from about 2015 till sometime in 2019.
Okay.
And that role was based in Colorado Springs, Colorado. So my wife and I moved from Bellingham to Colorado for that job. And then for some family reasons, I had to move back to Bellingham. And, you know, keep in mind, this is before the pandemic, so there weren't working remotely was kind of not a thing.
Yeah.
But SRAM was really amazing, and they were very understanding as to, you know, the reasons I needed to move back. And I wasn't able to continue being the rear shock product manager because that's a job where you really need to be hands-on.
Yeah.
But they did keep me employed, and eventually I found my way to taking care of communications for North America and Oceania. And so it's been a big transition for me, being someone who worked in product for all of my career and then moving over to the communications side of things.
Yeah.
But it's been really good, and it also provides, I think, you know, you and your listeners with the opportunity to get someone who has like worked in product development on the suspension side of things and on complete bikes, made it in the ability to kind of like speak to it in these contexts.
Right. It's really interesting, the interaction between the shocks and the bikes, like the frames, and because every frame, I mean, especially obviously we're talking about rear shocks and how each frame is designed in terms of the linkages and the progression and all that. Like, it's really important to consider that when you're looking at the shock and how it interacts.
Totally. And I mean, I think, there's the interplay between the kinematics of the frame, the stiffness of the frame, how that interfaces with how the shock is designed and what you've designed the shock to do. Mm-hmm. And then there's also the component of, our OEM partners are looking for their bikes to ride in a specific manner. Mm-hmm. And so a lot of the tuning work that we do with them is to achieve whatever that customer's goals are in terms of the performance of their product.
Right.
So you could have two companies that have relatively similar leverage rate curves, and they'll make totally different tune decisions simply based on how they're looking to have that bike ride.
Yeah. Yeah. And before we jump into kind of talking about that too, you mentioned that RockShox is in Colorado Springs. It's a part of SRAM, which is, mega big corporation, I believe, mostly based around Chicago area, right? But they've kept RockShox in Colorado Springs. Obviously, that's somewhere where you can do a lot of testing and that sort of thing. Like, is that the idea behind sort of keeping RockShox separate and giving it kind of its own space?
Yeah. So when SRAM acquired RockShox, they were based in Colorado Springs, and that's where the development and actually at the time the manufacturing was. We actually do quite a bit in Colorado Springs. So all of our hydraulic disc brake systems are actually also developed in Colorado Springs, as well as just a bunch of other things happen there. I think SRAM really is a global company. So we do have a lot. Chicago is where our headquarters are, and we do a lot of industrial design and product development there. Mm-hmm. But we also have facilities in San Luis Obispo, Spearfish, Indianapolis, and then obviously the Colorado Springs office. And then, we do quite a bit of development in Schweinfurt in Germany. Okay. And then we have a production facility for chains and zip wheels as well in Portugal. And then we own our own factories in Taiwan and do quite a bit of work there. And there's actually a couple of locations that I'm leaving out in this. Just my point there being that we have very global presence, and it gives us a really broad perspective of what the cycling community needs, and allows us to be members of a lot of different communities across the world, which allows us to see trends as they come up. I think a lot quicker than we would if we were centralized in one location. Yeah. Another place where we have presence is I work from home in Bellingham, Washington, but just across the border in Vancouver, we have an office with, I want to say 14 individuals there, but don't quote me on that. Oh, wow. So, we really are a global company with an eye towards how cycling exists across the world. Yeah, right. So many different styles of riding and terrain and everything. Yeah, and it sounds like I had no idea that SRAM was like that kind of decentralized in terms of the development and the different things. And it sounds like you're able to take advantage of kind of the experts in those places and like really getting a good sense of the way that people use their bikes. So let's talk about mountain bike suspension. Mountain bike suspension, to me, it's relatively new. I mean, it's like, we've been having suspension on mountain bikes since the late 80s, early 90s. But obviously suspension has been around for things like cars and motorcycles for much longer. So what's different about designing suspension for bicycles versus those other larger vehicles? Yeah, so it is interesting to know that RockShox has actually been there from the beginning of suspension on bicycles. It is quite a different thing. Whilst I haven't directly been involved with designing suspension for motorcycles or automotive applications, bicycle is a different thing. Mm-hmm. On a car, you've got a motor, or car or motorcycle, you have a motor. The bulk of the weight of the system, so the vehicle plus the occupants, is in the vehicle, not in the occupant, not on the individual. Yeah. And that center of gravity doesn't really move around, or the center of mass rather doesn't really move around. Right. You also, while weight on some motorcycles is a consideration, it's not the massive consideration it is on a bicycle. So that's another characteristic.
Mm-hmm.
And this may sound a little bit trivial, but we're trying to have an experience to connect with the outdoors whilst we're riding our bikes.
Mm-hmm.
Noise is another really big thing. I don't know if you've ever heard a motorbike just coasting down the hill with the motor turned off, but there's a ton of chain drag, there's a ton of plastic slaps. And then you think about the motor being turned on and like you really can't hear any of the noise that your suspension is making.
Right.
But on a bike, you really notice if your suspension is making like slurpy, crazy noises, and it's quite distracting.
Yeah.
So as trivial as it sounds, we do actually spend quite a bit of time making sure that our products are quiet so that you can have like a connected experience, an experience on your bike that's connecting you with the trail. That sounds simple, but in bicycle suspension or any suspension actually in this particular situation, you're moving some amount of oil from like relatively high pressure zones to relatively low pressure zones. And when you do that, you have a lot of like eddies and vortexes that are created. And that's what creates that kind of like slurping noises.
Yeah.
And so you have to be really careful with the way you design those transitions from the high pressure areas to the low pressure areas so that the oil flows smoothly in between the two of them and doesn't create noise. And that's something that we do on shocks and something that people will have noticed, especially in the MY23 Charger 3 damper that we came out with. It's very noticeably quite a bit quieter.
Interesting.
Something we pay attention to.
Yeah.
So there's a lot in there, but like the noise one is a really easy one for everyone to kind of like quickly imagine as a pretty big difference.
Yeah. And anytime there's noise, I mean, that's like energy. That's an energy loss. And I feel like, obviously most bikes, I mean, we have electrics now, but for the most part, bikes are human powered and we want to conserve like every ounce of energy that we can and put it back into propelling the bike. And then obviously that adds complication as well because you've got those like pedal forces. Like you said, our bodies are moving around and our center of gravity is constantly shifting. So yeah, it seems like a super big challenge.
Yeah, I think that's what you just pointed out there. I think there's two layers to it to highlight, like pedaling efficiency and then rider body position changing on the bike. Mm-hmm. And in both of those instances, we're developing suspension to maintain stability. So maintain stability in that not reacting to pedal inputs and making sure that like as a rider moves around, the suspension moves around on their bike, their suspension responds in a consistent manner. Mm-hmm. Doing all that while also being very responsive to inputs at the wheel.
Yeah.
And so you have to kind of think really carefully about like what shaft speeds and how you're going to build a system to sort of deal with those two sets of inputs.
Yeah. Yeah. And so continuing that vein of, thinking about energy, how it's lost and returned in a shock. Another thing that maybe it's a minor thing, but is heat management important for the average rider in a shock? Like do shock temperatures matter and how do you deal with that?
Yeah, so shock temperatures do matter. You do heat up your system a number of different ways. So oil moving through the shock there's friction with oil moving inside of a shock. Mm-hmm. You also have in an air spring system, you'd also have the adiabatic process, which is when you have very, very fast shaft speed. Mm-hmm. There's a point at which the shaft speed becomes so quick that there isn't enough time for pressure to increase in the air can. Mm-hmm. Just from the physics side of things, the pressure can't shoot up that quickly. Yeah. And so that energy goes into creating heat instead of going into creating an increase in pressure. And then that is dissipated. Yeah. So it's definitely something that we pay attention to. Some of the differences in feel between a coil spring and an air spring would be a result of that adiabatic process. Okay. But it's something that we're aware of. We know what the max temperatures for a given ride experience are going to be. Mm-hmm. And we develop our systems to primarily our rebound system, because that would be what would be the first impacted by it all, to manage that as best as we possibly can. And I think there's some kind of like surprising pieces in there. Like, you're going to see a higher absolute temperature on a coil shock than you would see on an air shock.
Really?
And that's simply because the coil shock has less surface area with which to dissipate heat, and surface area is what's going to allow you to sort of bleed that off into the environment as quickly as possible. Another little like tidbit is it's not necessarily the like highest speed trails that end up generating the most heat in the shock. It actually tends to be slower speed trails that have really big compressions that result in generating more heat, simply because you have less airflow over the shock. So the heat, more temperature is able to build up. Right. So yeah, it is something that we consider, and it's something we pay attention to as we're developing products. It shouldn't be something that really impacts the end rider in their riding experience, but it's definitely it's one of the things we pay attention to. Yeah.
That's kind of what I was wondering is if the average rider is actually pushing the shocks to that level, or if this is something that, really we're just talking about like pro racers who are going to notice maybe a little bit different performance, like at the start of the run versus the end of the run.
I think it has less to do with in terms of like how much heat is going to be seen. Pro racer versus like really astute amateur. It's probably has more to do with like the trails and the trail situation that's being ridden on.
Okay.
But again, like really, we're very aware of like what the boundary cases would be, or like the worst case scenarios are. And we design our systems as best we possibly can to sort of manage that. And we do that through various different ways, like the surface area, like as I kind of mentioned already, the surface area of the shock, the amount of oil in the shock, what type of oil we use in the shock. Yeah, there's just a bunch of different factors that kind of go into that.
Yeah. And so that kind of leads me to my next question about testing and development. How much of testing for suspension components is real world versus lab based? I imagine it's a mix of the two, but which one is like, are you spending more time on, or are you learning more from?
Yeah. So I actually think this is I'm really glad you're asking this question. They go hand in hand is really the answer to that. We'll have an engineer develop a thesis for something. For example, they'll say high frequency vibrations are what leads to hand fatigue in riders. And then they'll say, okay, can we develop a suspension technology that reduces the amount of high frequency vibrations that reach the rider? And then they'll develop a technology. In this specific case, I'm referencing buttercups in the fork.
Right.
And they will do blind back-to-back testing with a rider. And that feedback will get written down.
Okay.
Then they will also do some type of lab test that checks off and puts high frequency vibrations into a system, and then has a way to test the end result of that.
Okay.
And the only time we go forward with a technology is when we have the theory. So like the hypothesis that the engineer had came up with, the lab tests, and the rider test, the blind rider test feedback, all pointing in the same direction.
Yeah. Interesting.
So if one of those was to like not line up, that would send us back to the drawing board to like keep iterating and keep thinking about what we're doing. Just to kind of give you like an even more sophisticated example of how this kind of plays out sometimes. When we were developing the model year 23 RockShox forks, so the new Zeb, Lyric, Pike with the Charger 3 damper and the buttercups, the lead engineer on that and his sort of main test engineer are the same size, and they actually forced themselves to ride the exact same setup on the same bike. And what they ended up doing was they built two identical bikes on the same day. Everything's the same pedals, fork, handlebars, grips, all of it. And they would go out and ride together, and one bike would have one thing that was different from the other bike. And what that allowed them to do was instantaneously switch bikes in the middle of a ride without having to do anything. They could just jump from one bike to the other, and it was the exact same ride experience, except for they had changed one thing on it.
Yeah.
And that allowed them to get really direct, really quick on-trail back-to-back comparisons that they could then flip around and test in a lab to see if the feedback that they were giving lined up with what the test data feedback was also giving. And that really is like what allowed us to get to a lot of the refinements that we had in the MY23 product line. So if we just stick with the Buttercups example for a second, if you take the Buttercups apart, the rebound and compression rubber bumper components of the Buttercup is actually different rebound and compression on the air spring side and on the damper side. And that really came from a lot of back-to-back testing and putting Buttercups only on the air spring, putting Buttercups only on the damper, having the rubber elements be all the same on each side, and then realizing that we needed to change them from side to side, changing the durometer of them, riding them at hot temperatures, riding them in cold temperatures, and really kind of parsing out what those systems needed to be for their specific application.
Yeah, that's interesting. I mean, it's almost not to minimize the engineering and the science behind it all, but some of it sounds kind of like guess and check, where you're just okay, we think maybe this is going to make a difference, but we don't know, do we put it on the rebound side or the compression side? Let's go out there and try it out. Are there a lot of things that you try and nobody can tell a difference? You do the blind test and it's kind of inconclusive?
Yeah, that absolutely happens. And to touch on the guess and check thing for a second, innovation and developing new things is a tricky, difficult space. You have to have your eyes and your ears open to what's not working today. And you have to see those things. A lot of times, at least for me, they come across as feelings, and it's different for different product developers. But, you basically, you come to understand a problem that could be solved. And then you really do have to display some courage and go out on a limb and propose some things that might sound crazy initially to solve those problems.
Right.
I think it's not guess and check might sound could potentially sound a little bit trivialized or maybe not serious.
Right. Yeah. You're not just getting lucky though. Yeah.
But it really is to properly guess and check, you have to make sure that you're not getting confused information. You got to make sure that your test is actually telling you what you think it's telling you.
Right.
So yeah, I think that's a good way to think about it.
Yeah, right. It's definitely iterative and yeah, you're not just guessing, just pulling things out of the air. There's the theory at first, and then you try something and it doesn't work exactly the way you thought it would work, but you kind of refine it along the way. And yeah, this is a fascinating process.
Yeah. And you can imagine that process. You come up with a theory, you try to test it in multiple different ways. Sometimes you have to look back at your test and make sure your test is actually telling you what you think it is. Cause you could not be seeing what you think you're seeing in a test. Which is why it's important to have experts, dyno, for example, which would, you put a suspension product on it, it applies force to it and then creates a graph. Well, if that dyno is not properly set up, if the tech who's operating the dyno doesn't know exactly how to read the graph, there's just a ton of factors that go into that. And that's a place where you could get led astray. And I've seen people get led astray really quickly by this really fancy machine. Again, if you don't know how to use it properly, it doesn't help you.
Right. Yeah. Yeah. And it's really interesting to see kind of behind the scenes and to understand all the testing that goes into this and, checking and double checking things and making sure that the solution is completely dialed before you come out with a new product. I think, on the one hand, we're there's always new stuff and mountain bike innovation is just so fast and it's always something new. But on the other hand, we're like, oh man, it's been like 3 years since they updated, XYZ product. And it's like, well, there's a lot that goes into that stuff. And these things can take time depending on what you're doing.
Yeah. It takes a ton of time and energy to innovate and to take those innovations and get them to like a production level thing.
Mm-hmm.
One thing as we're kind of going back and forth about this, and I'm like thinking about, how this ends up landing down to the rider and like the ride experience that you have on the trail.
Mm-hmm.
One of the things that pops up to me at that point in my mind there is the first step that a lot of those engineers are doing when they're getting onto a product is they're making sure that their setup is correct.
Mm-hmm.
So like they're making sure their air spring setup is correct. Then they're making sure that their rebound setting is correct for the spring that they have.
Mm-hmm.
And then, they're making sure that compression choices that they've made on the fork are going to tell them what they need to know for the ride experience or are appropriate for the trails that they're going to ride.
Mm-hmm.
So I think one thing for all these listeners to keep in mind too is like the really basic things of like setting sag, setting rebound, and being attentive to those details is a shared experience between a rider on a trail in Arizona or Spain. That is also the same experience that one of our development engineers would be having in Colorado Springs.
Yeah, right. And so, that's a really great parallel, is this experience of like designing and testing is something that we as riders need to do as well, whether we like it or not. Like that's the only way to set up your suspension properly. So why don't we talk about that? Like what's your method for setting up a new fork or a new shock? Like what's the process like?
Yeah, so it's a little bit different forks and shocks, but not too terribly different. And I do think we spend a lot of money on these bikes. The suspension is a big percentage of that spend. And as much as like it would be great if there was a silver bullet to do it isn't like that. And it does really help your user experience if you take the time to do proper setup. So we have invested a lot of time and energy into our app, which provides a really good initial setup for the fork and the rear shock, air spring, and the rebound setting.
Okay.
And the way that I like to think about this is like you're looking to get inside your window of happiness.
Mm-hmm.
So there's like settings where you'll be unhappy, which would result in you being outside of your window of happiness. And then there's the settings that like get you into your window of happiness. And those like starting suggestions really are aimed at like getting you close to your window of happiness, getting you to inside the window of happiness so that you can then kind of refine from there.
Yeah, that's a good way to put it, because a lot of us, we get a new fork, and I don't know, I haven't set up a new fork in a while, but it used to be there's like a chart and you find your weight on there, and there's like a recommended pressure that you start with. And I think for a lot of people, they're just like, yep, that's it, like I'm done. But yeah, it sounds like that's just kind of the starting point.
Yeah. And I mean, that recommended pressure should get you into your window of happiness. It should be a really great place to start.
Mm-hmm.
Taking it to the next level, really requires going out and like riding your bike, ideally in a relatively systematic kind of a way.
Mm-hmm.
And what I like to do and what I suggest that people do and what we do when we're doing suspension testing is we will take someone to a piece of trail that's representative of the kind of riding that they're going to do or the bike is intended to be ridden on.
Okay.
Sure. Like you want this to be 30 seconds of trail. 2 minutes is great. 5 minutes is probably kind of too long. Mm-hmm. And ideally you can lap it and do quite a few repeats on it.
Mm-hmm.
And so start off with those recommended pressure settings.
Mm-hmm.
In the fork, use the guide, the recommendation from the Trailhead app. You can also use that for the rear shock. On the rear shock, you could also set sag, which is another really great way to do it. Aim for 30%.
Mm-hmm.
And then do a lap down that section of trail. And you don't need to write it down or unless that helps you, but just kind of like your impressions of what that was like. Like, what did you feel at your hands? What did you feel at your feet? Did you feel like you were way forward on the bike? Did you feel like you were way backward on the bike? Just kind of like think about some questions about like what and like feelings about what you were experiencing.
Yeah.
And then go back up and do another run, which may seem redundant, but you kind of want to get warmed up and you kind of want to see if you had the same experience on the previous run as you had on the last run.
Mm-hmm.
And then it gets a bit open at that point, because what you're really trying to do is you're trying to say like, what am I experiencing that I don't like or could be improved upon? So let's say, for example, you do that run and you're like, wow, I feel a lot of weight in my hands and I don't actually feel like much of my weight is on my feet. And kind of feel like my nose is over my handlebar. That might suggest that your rebound is too slow on your fork, or that you don't have enough air pressure in your fork and you're ending up really far over the front of the bike.
Yeah, makes sense.
So if someone came to the bottom and gave me that feedback, I might try making a minor adjustment to their fork and then having them do another lap and seeing what they think. A different example of what the feedback could be is they come to the bottom and they're like, I clacked bottom out twice coming down that.
Yeah.
And it's okay to bottom out. Like you do want to use full travel. But if clacking bottom out twice in a relatively short run on a piece of terrain that doesn't feel appropriate for that would tell you like, oh, we should bump up your air pressure, or think about increasing the ramp in your air spring. So this is where it does get a little bit open-ended, and you really have to listen to yourself as a rider and recognize that like you are the expert in that space. Like it's you who is going to be riding their bike down the trail. It's you who needs to be comfortable, and you should feel comfortable making changes to the suspension on your bike to try to improve your experience.
Yeah. Well, so what does someone do? I mean, is there like a decision tree kind of? I mean, you mentioned a couple of examples of like, if you're feeling this, do that. Is that part of like the Trailhead app, or is there a way to like dial in your suspension without necessarily knowing all those things, and maybe like starting in the middle or starting at one end and working your way the other direction? Like, what do you recommend?
Yeah, so the starting point there is that Trailhead app and the recommendations that would give you in terms of like rebound or airspring rebound. And then going from there, I mean, the decision tree really is like what you're feeling and experiencing on the trail, and like how you want to change your ride experience based on what you're feeling. Yeah. We do have technologies that can help in that space. For example, ShockWiz is a really good aftermarket component that you can bolt onto your fork or your shock, and it will offer suspension setup recommendations. So that's a really great tool if you feel like you don't have that. But I also think like it's not a static thing. Like you can do this one time, feel that experience, go on, make some changes, or stick with the settings that you have, and then carry on riding your bike, do it again a couple months later and see if there's a change in your experience. Personally, like I changed my suspension settings over the course of the summer. The beginning of the summer, I've been skiing a little bit more than biking. And by the end of the summer, I've just been biking. And so my fitness is transferred completely over to biking. And so I end up running like a little bit different suspension setups. We also have like, this is another like pretty big factor. For me, the terrain that I ride on changes pretty radically from winter to summer. It's pretty soft dirt in the winter. There are wet routes. The trails run relatively slow. And then summertime, the ground gets really hard packed. The routes are very dry. The speeds increase quite a bit. So I think that's one of the other things that everyone should keep in mind is like, it's not a static thing necessarily. You can make it a static thing. Like if it is best for you to maintain very consistent suspension settings, then you should do that. That might be the best thing for you because it gives you the most consistency. However, you can also adjust your setup based on time progression, but taking the time to think about your setup, leverage the starting point that should get you into the window of happiness in the Trailhead app, and then going out and like systematically riding on a short section of trail, making a change, riding it again, making a short a quick change. Those are the kind of things that can be really helpful in getting you to like the next level of performance.
Yeah. I mean, it sounds like obviously, right. Going through that process is super helpful, but yeah, it also sounds like it really pays to understand how the suspension works. And if you're feeling this, then that means that you need to do that to your fork or your shock. Because like you said, our fitness changes, our riding style changes throughout the year, or, as we progress, trails change. I mean, there's so many things that change that it doesn't really make sense to just say like, oh, well, I always run 3 clicks on rebound and, -2 on compression. And like, that's it. It doesn't sound like that's necessarily going to give you the full advantage.
Yeah. And, I think it's a bit of a learned thing too, right? Like let's say you tomorrow decide you're going to try this out and you go out and, you could do a run with your fork at the current air pressure, do a run with your fork with a few PSI more. And then you could do a run with your fork at a few PSI less. And that set of runs would give you a bracket for how your fork changes with more or less air.
Yeah.
And then your mind and your body at that point would understand how that change impacts you as a rider.
Right. That's a good point. I hadn't thought of that process in that way before, right? Like, I think for me, that process was always about like finding the number, but it sounds like it's really about learning and understanding the relationship between the number and what you're feeling.
Yeah. And, I think we spend so much time making sure that our suspension recommendations in the Trailhead app are going to get people to like inside the bubble of the window of happiness, like in that space.
Yeah.
And then for a lot of people, that's like great. And they can ride in those settings for their entire ride experience. But for other people, it's important just to sort of like refine and take it to the next level. And for those people, that's where doing something like this and being systematic about it is helpful. And, if you think about the people who have spent a lot of time working on suspension and diving into suspension, they weren't born with an innate ability to parse out the difference between a digressive rebound tune and a progressive rebound tune.
I'm glad you said that because I'm always confused when I start talking to those people and I'm jealous. I'm like, I can't wrap my head around this, but yeah. It's probably just because I haven't experienced it enough.
Yeah. So what those people, the thing that those people have done is they've spent a lot of time doing a run, making a small change, doing another run. Now, they might be changing between 2 shocks that have 2 different shim stacks in it. And that's one thing. But another version of that is if you're currently riding you have a shock that has 15 clicks of rebound and you're currently riding at 9 from closed, try doing a lap on 7 from closed and try doing a lap on 11 or 12 from closed.
Yeah.
And if you do that, you will feel the difference between those 2 settings. Or those 3 settings. Yeah. And then you'll know what rebound is doing for you in different circumstances. So like you will feel a difference in that rebound, both on like small bumps, but you will also feel that change in bigger compressions that are using more of your travel.
Yeah, that's super helpful. And yeah, it definitely motivates me to get out and do more of that type of testing, hopefully for listeners as well. Because yeah, it sounds like there really isn't a substitute for that. And yeah, if we want to understand this and we want to dial in our bikes more, this is just the way to go.
Yeah. And I mean, I think that starting point of what you get from the Trailhead app in terms of setup, initial setup is really great.
Yeah. Well, let's get back to talking about some of the technology behind suspension systems. So we talked about heat management, and you mentioned the ShockWiz as like sort of a way to monitor your shock and understand performance more. Tell us a little bit about electronic suspension controls. What does that do for people? And for SRAM, that's the SRAM Flight Attendant. So what's the idea behind Flight Attendant?
Yeah, so this is is different from ShockWiz. ShockWiz is aimed at giving you feedback on your suspension setups. Flight Attendant is aimed at increasing the efficiency and your overall ride experience on your bike. So for years now, it's kind of been the holy grail of suspension has been giving you a ton of efficiency while also being able to absorb bumps at any moment. Kind of spoke earlier about how bicycle suspension design is quite a bit different from like automotive suspension design because of that. The added feature that we get with Flight Attendant is because we're able to integrate the full system and get much closer to the rider's intent with an electronic system. It allows us to provide the rider with a much more efficient ride experience. So, i.e., more of your energy, more of your pedaling power going into forward momentum in a way that is just not possible with other systems. So yes, we do provide cable lockouts, and lockouts are a thing, but that requires a lot of mental application by the rider. Whereas Flight Attendant, you don't have to do anything. You just get onto your bike and the bike does the work for you.
Yeah. I mean, it seems like, almost too hard to believe because like, how does it know? How does it sense kind of what the terrain is? The way I've heard it described is kind of that it's like able to react quicker, obviously quicker than the rider can. How does it distinguish different inputs from each other? Like, how does it know that you're just starting to hit a big rock versus like you're just hitting a small rock and you're already almost over it?
Yeah. So in terms of like how the fork and the shock deal with like the inputs to the wheel, that's like basic's not the right word, but like we put a lot of work into the accelerometers and how the information that's coming from the vibrations in the fork, the vibrations that the fork and the shock are seeing, be those big impacts or small impacts, and how the accelerometers in the fork and the shock sort of manage that input and then change your state based on that. And then the other piece of information that we use to infer rider intent is the pedal sensor, which is based in the cranks. And so what we found as we were developing Flight Attendant and we had sensors all over the bike, and we were looking at a ton of different pieces of information to try to parse out rider intent, what we realized is pedaling input gives you a lot of information about what a rider is intending to do on the trail. It doesn't tell you the whole story, but it tells you a lot of it. So by putting the pedal sensor into the system along with pitch detection, so like if you're going up or if you're going down, history is also a piece of information that we use to predict the future. So the Flight Attendant algorithm knows what has happened in the last few moments and uses that along with the pitch information and then the rider input in terms of whether the rider's pedaling or not pedaling to think about what the future sections of trail could look at and make a decision based on that, telling it which state it should be in.
Interesting.
So the point of all that, I guess I would say, is like the element of the vibration or the impact sensor in the fork module and the rear shock module, and then the ability for our system to flip to open is a component of Flight Attendant, but it's wrapped up in this bigger package that the algorithm combines together to paint a more accurate picture of what's happening in the future and what the rider is looking for at that moment. Is the rider looking to have open, bump gobbling suspension state, or are they looking for a little bit of pedaling efficiency, or are they just pedaling up a road and we can go to full lockout? And those are the kind of layers that I think really make Flight Attendant kind of a magical riding experience where you as the rider just get on your bike and ride without having to use your brain to get to a more efficient compression state. You can just ride your bike, and the bike is going to create the most efficient state for a given moment.
Yeah, that makes sense. Right. It definitely, I'm sure that our bodies kind of tell us what's about to happen. Like you're saying, if we see a big rock coming up, like our pedal stance is going to be a little different than if, it's just a minor bump. And so, yeah, I guess having all of those inputs, you really can make some good predictions about like where the suspension should be set and all of those things. So very cool.
Yeah.
So what about inverted fork designs? Why don't we see more of those? Every suspension person I talk to is like, oh, it's the best design. It's amazing. Like, it's clean and, super efficient. Like, why aren't all forks inverted?
Yeah. So, I mean, we've done inverted forks, before. The RS1, I think was like the most shining example of like a really elegant, effective inverted design.
Mm-hmm.
However, the technology today really lends itself to the current setup of forks with having magnesium lower legs and aluminum upper tubes. Just in terms of efficiency of design when it comes to the stiffness to weight ratio, ease of maintenance and working on it, ensuring the entire system is well aligned. Mm-hmm. The ease of getting wheels on and off, cable management. There are advantages to inverted designs, but there are a lot of costs that come along with that. And when we look at like the problems that we're trying to solve, the traditional fork design is the most efficient way to do that.
Yeah. Yeah. And you mentioned, I think you mentioned stiffness as being like one of the challenges with that. What about stanchion diameters? Is that also being driven by stiffness, or are there also like suspension properties in terms of like the volume of air that you have in a fork that makes a bigger stanchion better for like longer travel bikes?
Yeah. So there's kind of a lot there. I would say first and foremost, when we are looking at stanchion tube diameters, it's the trade-off between weight and stiffness performance based on the length of the fork too. So like, the longer your fork gets, the more travel you're adding, or the bigger the wheel size, the easier it becomes to solve and get to the correct stiffness with a bigger upper tube. So that's really kind of the dynamic that's at play there. And then in terms of how that fits in with the airspring side of things, we have a ton of levers that we can pull on the airspring side of things. And so, we, between negative airspring volume, positive airspring volume, and all those different things, it allows us to sort of build the different airsprings we need based on the upper tube size.
Okay. Yeah, that makes sense. So let's talk about some misunderstandings or misconceptions about mountain bike suspension. What are some things that maybe you'd like to clear up that maybe people might not understand about mountain bike suspension?
Ooh, I mean, I would say I don't know if this exactly answers your question, but the first thing that comes to mind to me, is in the motorcycle space, there is like a really strong ethic of getting your product serviced at the exact service intervals. Yeah. And I think cyclists struggle with that a little bit. And I would say the misconception is that you can just run your bicycle suspension fork or your dropper seat post forever and it'll be fine. Yeah. And what I would say is, no, you should be attentive to your service intervals. And one thing you'll notice is, first of all, you can Google SRAM service intervals and you'll see we have, on one consolidated page, our service intervals for brakes and suspension all together. And we spend quite a bit of energy and time trying to make sure that like we block that stuff off so that, you're not like bringing your fork in to get serviced and then 2 weeks later you've like put another 10 hours on your rear shocks. You need to get your rear shock serviced. You can do those two things at the same time. And it really does like have a big impact both on like how much value that product is going to provide to you over time, because it's going to last longer, but it also is going to give you a better riding experience over time.
Yeah. Yeah. Well, but do people need to be like, it says 100 hours, like right at 100, you need to get it serviced, or is it kind of depending on how you ride and your conditions and that sort of thing?
Yeah, there's a bit of like how you ride and your conditions. For example, like with our dot brakes, we recommend that you bleed your brakes, replace the fluid once a year.
Mm-hmm.
Now, if you're riding in a very aggressive place like Morzine in France would be a very good example of quite a steep place. Whistler would be another example. That might be a place where you want to do it a little bit more often than that. And then on the suspension side of things, like 50 hours would be your like lower leg and air can service on your fork, plus or minus some number of hours on that front. You don't need to do it exactly at 50 hours, but like 50, if you're in the ballpark at 50, it's going to make your product last longer and it's going to give you a better ride experience.
Yeah. That's a tough one for a lot of people, I think, because I mean, we ride a lot, right? Like we just did a survey asking Single Tracks readers like how often they ride. And, for most people, it's at least 2 or 3 times a week. So even if you ride like an hour a week, you're at 50 hours in a year, right? And people are doing like 10 times that. So, I mean, are we really going to be servicing our forks like every couple of months? I
mean, to keep that product working in tip-top shape, that is our recommendation. That's
yeah, wow.
That is going to result in like the product lasting for as long as that rider wants it to. And it is also going to give them the best like feel in terms of performance. These are like pretty high-end products. Like they're, we're not talking about like Formula One stuff that has to get rebuilt every single race. But for example, I was just looking at automotive brakes. You're supposed to have maintenance to your automotive brakes every 6 months or 20 to 60,000 miles.
Wow.
Which is a lot. and like, I was surprised by that, how often that is.
Yeah.
But again, it's kind of the same thing. Like these are sophisticated products that are designed to provide high performance and that requires some level of maintenance.
Yeah. Wow. Yeah. I mean, I'm just doing the math in my head. And if I do like 2 to 3 rides a week and each one's an hour to 2 hours, I mean, that's every 10 weeks that I need to be, checking that stuff, which, I mean, that I'm sure most people don't do that. And so it would be interesting to see kind of what benefit you get from that. Cause maybe, I mean, the other thing is we don't notice kind of that degradation in performance over time either. And so, it's easy to think like, it's fine. It still feels good. Like, but you don't realize that it doesn't feel nearly as good as it did when you first got it or, since the last time you serviced it.
Yeah, I think that is a super good reason to keep thinking about this is like things do degrade over time. You replace it, all of a sudden you have new, fresh, clean oil and grease in the places that it should be. Yeah. And it's just like a better experience. And I also think, it's a good way of maintaining the value in the investment that you've made. We've all invested a lot in these products and like we want the value to be maintained over time. Fully switching gears from suspension, like one of the internal use cases that we discussed with transmission and making the skid plates on the derailleur replaceable is like, if your derailleur gets scuffed up and you want it to look nice for your own personal enjoyment of it looking nice, or you want it to look nice because you're going to sell your bike now and you want your derailleur to look fresh on your bike, those are two like very valid use cases for like making that outer skid plate replaceable on that derailleur. And I think suspension is the same situation. I recently purchased a bike for my daughter on Pink Bike Buy and Sell. And one of the like features of the ad that the individual who was selling it posted was that the suspension on the bike had been recently serviced. And I was drawn, that was the specific model of bike that I wanted to get for my daughter, but I was also drawn to that advertisement, that specific ad on Pink Bikes Buy and Sell because I knew that individual had clearly taken care of the bike.
Right.
So I think there's a value to you as a rider to have that, but there's also a value to your long-term investment there.
Yeah. How much of that is considered during the design process, like the serviceability? Because, suspension components are kind of unique. I mean, that's one of the few things that a lot of local bike shops are not set up to handle because it is so complex and there are a lot of special parts and tools that you need. So is there like a path to making this easier for folks or even just for local bike shops to do? Or is this always going to be kind of like a specialized process for working on suspension?
So we've spent, and I think like you can see this from our YouTube channels and like you can see this from our YouTube channels and like how much energy we invest in making sure that there are the small parts kits and the knowledge of how to work on the products is really widely disseminated. And if we go back to like the most common service that would happen, which would be like a lower leg service at 50 hours or an air can service at 50 hours, they don't require you to go into the pressurized side of the system. Like it's all on the unpressurized side of the systems. And it's not trivial, but in terms of like technical know-how, it's pretty straightforward stuff. And most mechanics could learn how to do it from watching a YouTube channel. And to be perfectly honest with you, the most important thing in either one of those processes is the cleaning aspect of it. So like making sure that before you open up your product, it is extremely clean so that you don't introduce contamination into the product is like, make sure you're not over torquing your bolts or under torquing your bolts. But like that cleaning step is really kind of like the most important one there.
Yeah, right. Clearly requires an eye for detail. And that's why you always see the folks wearing the rubber gloves and everything doing it. Cause it is gotta make sure you're keeping it clean.
Yeah. And, I think I personally interact with a lot of mechanics at bike shops, and I have a high degree of respect for the level of know-how and like the interest that they have in learning more. You can imagine when I walk into shops, I get a lot of questions about a lot of things. And I always really, really appreciate those individuals because they are taking advantage of every opportunity they can to learn more so that they can be better at their trade. And they're members of our community, like the bike shop employees are like people a lot of times who are building the trail or like out there making sure that the kids know how to like ride their bikes safely and properly.
Yeah.
So for me, I think it is something that like keeps the cycling community going, as well as like being a good way to maintain the value of your product. Yeah,
for sure. And there are so many, I mean, I forget too, right? I'm a mountain biker. I ride gravel every now and then, have a gravel bike, but for me, like biking is mountain biking, but you go into a shop and you realize like, oh shoot, like there's road bikes. I know nothing about road bikes. Like there's so much that they have to know and understand. And suspension is just like one piece of one type of bike that they work on. And so, hats off to bike shop mechanics for sure.
Totally. I always chuckle to myself a little bit because I feel very comfortable working on rear shocks. I can take them apart, put them back together. It's fine. I definitely still experience a bit of anxiety when I have to do handlebar tape, which always makes me smile.
Right.
Like I would be very nervous about doing handlebar tape for anyone other than myself.
Yeah. Right. I think it just depends on the person too. Like you said, like if you're working on suspension, you got to be very clean and detail oriented. Whereas, for other stuff, maybe you can be a little more ham fisted and, different strokes. So finally, I want to ask you, which suspension innovations are you most stoked about? Like new stuff that's maybe already out or stuff that maybe could be coming in the future? Like what's kind of the big deal in suspension right now?
Yeah. So there are some things coming in the future, but unfortunately I can't talk about them.
Yeah. But you're really stoked about them, and we will be too, I'm sure.
But I also think like what we have access to today is pretty amazing. You know, the two things that come to mind when you ask that question, one is buttercups, which we introduced with our MY23 RockShox product line.
Mm-hmm.
And I think that is a innovation that I really like, because I think it just reduces a lot of hand fatigue and allows
mm-hmm.
riders to push harder, further, on a longer descent. So mm-hmm. that one comes to mind. And then the other innovation that I like, which is like very in the weeds, is the base valve that we developed on the Charger 3 damper, which has a really specific oil flow path that reduces and actually eliminates the rebound noise in the fork damper.
Oh yeah.
There's a bunch of really cool, neat little features in there, and I still every time I ride that fork and it's quiet, it makes me smile. And then I also know like how much blood and sweat was expended to get to that.
Mm-hmm.
I think it was worth it, because it creates a really good riding experience, because you get to ride in silence.
Yeah, right. Yeah, I mean, what a great place that we are today, where it's the little things like that that get us most excited, because, you know, I mean, suspension is really great, but there's still these like areas where we can now take some time and be like, okay, like, can we dial this in, and can we like make it quieter? Can we, you know, reduce these vibrations that have always been there, but nobody really thought like, oh, maybe we should do something about this. Maybe we can do something about this. So yeah, super cool.
Oh.
Yeah. Well, Chris, thanks so much for taking the time to chat with us. I learned a ton, and there's actually, I mean, we had other stuff to cover, but ran out of time. So we'll have to do this again, but thanks for joining us.
Yeah, I really appreciate the opportunity, and I hope this was helpful and informative, and I'm down to do it again. Maybe you can get some feedback from the listeners on what they want to hear round 2.
Yeah, that's a great idea. Yeah. So if you're listening and you've got questions about mountain bike suspension, definitely hit us up and let us know, and we'll be sure to send these over to Chris. And then also, yeah, check out the SRAM website, SRAM.com, and look up those YouTube videos that'll help you get your suspension dialed in and hopefully answer any other questions you might have. That's all we've got this week. We'll talk to you again next week.